given that x is equal to 2 plus 2e to the power negative 2t minus e to the power negative 3t, find the maximum value of x as t varies. For us to find the maximum value as t varies, it means we have to find, first of all, the derivative of x with respect to t, pardon me. Then we substitute it and get the y value as well. Dx by dt is equal to the derivative of a number which is 2 is 0. So 0 plus the derivative of 2e to the power negative 2t with respect to t minus the derivative of e to the power negative 3t over dt. Okay, I just want to break this down easily for you guys. So let's take this second part and differentiate it using the product rule. Okay, so this derivative de negative 2t dt, we can keep 2 constant first, and then we differentiate e to the power negative 2t. The derivative of e to the power negative of 2t would be negative 2 multiplied by e to the power negative 2t. That's basically it. Then you would get negative 4 e to the power negative 2t. The derivative of this one right here is easy as well. So the derivative of e to the power negative 3t would be differentiating the power, which is negative 3, then multiplying it by e to the power negative 3t, so that we get the same thing basically. There's nothing to simplify here. Let's substitute into our main equation. Dx by dt would be 0 minus 4 e to the power negative 2t plus the negative, we put the derivative here, negative 3e to the power negative 3t. This would be negative 4 e to the power minus 2t plus 3e to the power negative 3t. That's the derivative. Now, the maximum value occurs when the derivative or the rate of change, which is this, is equal to 0. So I'm just going to equate this to 0 right over here, so that we can work out the value of t, the time at which this occurs. So now I'm just going to go ahead and add 4e to the power negative 2t on both sides, so that we have 4e to the power minus 2t equals 3e to the power 3t, pardon me, this is even supposed to be negative. Okay, simplify. So I would divide both sides by e to the power minus 3t because that's the smaller number. So I'm going to get rid of e to the power minus 3t, just like this. And I'm just going to create more space real quick. There we go. We use the law of indices. This will be 4e to the power negative 2t minus e to the power negative 3t. And then over here we have 3e to the power, oh, it cancels out, so we have just a 3. And then we're going to have 4, negative 2 plus 3 is 1. So 4e to the power t equal to 3. So therefore e to the power t is 3/4. Therefore t, if I take the natural log on both sides, so the natural log of e to the power t should be equal to the natural log of 3/4. So t is ln of 3/4. The actual value using the calculator would be t is equal to 0.287. Okay, now that we know where this maximum occurs or what time it occurs, we can substitute to get the x value. So x would be 2 plus 2e to the power minus 2 times 0.287. This is a negative number. When you do a natural log of a number, you should get negative, so this is supposed to be minus, pardon me, plus negative 3e to the power negative 0.287 times 3. Okay, so you can actually work that out with the calculator. So x would be equal to 3.185, and therefore maximum value at which this occurs would be negative 0.287, 3.185. There we go. Let's move on. Question number 9.